السلام عليكم ورحمة الله وبركاته، ازيكم يا شباب؟ نكمل النهارده برضو تريجنومتري. اوكي، هنشتغل طبعا نفتكر كده مع بعض بس الرولز القديمة بالنسبة للتريجنومتري كنا خدناها قبل كده مع بعض. طيب هنبتدي طبعا بتريجنومتري فانكشنز. اوكي، طبعا لو سمينا ترينجل اي بي سي، ترينجل اي بي سي رايت انجل ترينجل at B measure angle C equals theta، يبقى اكيد measure angle A equals 90 minus theta. اوكي AC طبعا بيلعب دور الهايبوتنيوز of this triangle. تمام. اوكي trigonometric function ساعتنا طبعا كان في عندنا الساين والتان. نفتكر على طول طبعا نشوف بقى الساين كوساين والتان. هنفتكر كده مع بعض على طول الرولز of these functions بتعبر عن مين. طبعا قلنا قبل كده انها بتعبر عن ratios between the sides of triangles. كان ك 2 sine opposite over hypotenuse, sine adjacent over hypotenuse, tan opposite over adjacent, opposite over adjacent, right? اوكي. طبعا هو تبقى كل رول من ديت فيها 3 ايتمز. لو في عندي 2 ايتمز هجيب الميسنج ايتم بتاعنا. بمعنى لما يقول مثلا السايد اي بي unknown but angle theta known, length of hypotenuse known، يبقى in this case AB equals what? Equals the hypotenuse times sine theta opposite equals hypotenuse times sine theta, right? Okay. Sine theta equal opposite over hypotenuse, hypotenuse equals opposite over sine. يبقى عندنا هنا اهوت sine theta equals AB opposite over hypotenuse AC. If we want to find the length of AB, so AB equals hypotenuse times sine theta. What about BC? Yes, right. It is the adjacent of theta, and the hypotenuse is known. In this case, BC equals hypotenuse times cosine theta. Hypotenuse times cosine theta. Okay? The same. Tan theta equal opposite over adjacent. Opposite over adjacent. And then opposite equal adjacent times tan. And adjacent equals opposite over tan. طبعا كل الرولز دي طبعا المفروض ديت قديمه بالنسبه لنا، ودي كانت اول حاجه تعرفنا عليها في trigonometric functions، وكان لازم نبقى عارفينها كويس جدا جدا جدا. اوكي. طيب for example if this triangle is of side length of its hypotenuse 1 unit length A B C, and this angle is theta. So in this case AB equals what? Excellent, sine theta times hypotenuse equals 1 unit, so 1 times sine theta, it will be 1 sine theta. And the BC equals what? Cosine theta. Excellent. In this case, the hypotenuse equals 1. Okay? Okay. Another example. Okay, like this one, approximately like this one. Okay, you can change it. Try again. Okay, I'm going to draw the other triangle manually. Okay. Like this one, not like this one. Okay, can cancel this again. Okay, and now this is theta, this is alpha, and this side length equals 1 unit. Okay, so this triangle ABC, then BC equals what? Excellent, sine theta. BC equals what? Sine theta. In this case, CD equals what? Excellent. Hypotenuse, sine theta. CD is the opposite of alpha, so sine alpha. Sine theta times sine alpha. And dB equals what? dB equals sine theta hypotenuse times BED is adjacent of alpha, so sine alpha. Okay? Okay. Now come to play, okay, another problem or another example to deduce something I want to do with you. Okay? Okay. You share this one. Okay. Now, in this shape, this side length is 1 unit, so denoted by 1 here in the white rectangle, 1 unit. The purple angle there is alpha, the blue one is beta. So if this alpha, then this is 90 minus alpha, this is 90, so this is 180 minus 90 plus 90 minus alpha, so it will be alpha. Same. This angle equals alpha plus beta. Why that? Alternate angle. Alternate angles, right? Okay. Now, triangle, this triangle, okay, is right angle triangle. Well, hypotenuse length 1 unit. So the side opposite to beta, it will be what side? Yes, right. Hypotenuse 1 times sine beta, it will be sine beta. So this side is sine beta. And the last side in this triangle is adjacent to beta. So its length will be hypotenuse times cosine beta. Its hypotenuse is 1. So it will be 1 cosine beta. So equals cosine beta. Okay. And the above right angle triangle, the above in the right corner, the above of white right angle triangle, which has angle of measure alpha. Okay, the side opposite to this angle, alpha, it will be what? Hypotenuse, which is sine beta times sine alpha. Sine beta times sine alpha. So this one equals sine beta times sine alpha. And the last side in this triangle is adjacent to alpha, so it will be equals sine beta cosine alpha. Sine beta cosine alpha. Excellent. The last white right angle triangle in the shape. That one is the blue triangle. Sorry, white right angle triangle in the shape. Okay. Its hypotenuse is cosine beta. The side opposite to alpha, it will be equals hypotenuse, which is cosine beta times sine alpha. Cosine beta times sine alpha. Right? So this will be cosine beta times sine alpha. And the last side in this triangle, it will be adjacent of alpha. So hypotenuse cosine beta times cosine alpha. Cosine beta times cosine alpha. So this will be here. So we know that there is another triangle, and this triangle is the last triangle, last right angle triangle, which is its hypotenuse is 1 unit length. Its hypotenuse is 1 unit length. Okay, and this side in this triangle, this side in this triangle is opposite to angle which its measure is alpha plus beta. So this side will be hypotenuse, which is 1 times sine alpha plus beta. So this side length is sine alpha plus beta. The last triangle, the last side in this triangle, which is adjacent to the angle of measure alpha plus beta, and its hypotenuse also is 1. So its length will be equals cosine alpha plus beta. Cosine alpha plus beta. The whole shape is a rectangle, and we know that the opposite sides of the rectangle are equal in length. So we have side length of this rectangle sine alpha plus beta, and its opposite side is divided into two parts. And the sum of these two parts must be equals sine alpha plus beta, the side lengths opposite to it. So sine alpha plus beta equals sine alpha cosine beta plus cosine alpha sine beta. And this is the first rule to find the sine of the sum of two angles. Sine of the sum of two angles. So sine alpha plus beta equals what? Sine alpha plus sine alpha cosine beta plus sine alpha sine beta. Okay? Okay, we know that if we move this point up and down, okay, it will be the same. No changes. No change. Right? Right. The other two opposite sides of the triangle. The other two opposite sides of the triangle. Yes, right. Cosine alpha, cosine beta. This is one side, the width of the rectangle. The width of the rectangle down, cosine alpha, cosine beta. It must be equals the opposite width. And the opposite width is divided into two parts. So cosine alpha, cosine beta must be equal to the sum of these two parts. So cosine alpha plus beta plus sine alpha plus beta equals cosine alpha, cosine beta. And if we subtracted both sides. Subtracted from the both sides sine alpha, sine beta. We know that cosine alpha plus cosine beta equals cosine alpha, cosine beta minus sine alpha, sine beta. Sine alpha minus sine beta. Again, we can see this video. Okay, now as we say that, okay, now we want to write the rules again. We have here the first rule, sine alpha plus beta equals what? Sine alpha cosine beta plus cosine alpha sine beta, and cosine alpha plus beta equals cosine alpha sine beta minus sine alpha sine beta. If we put here negative beta, so it will be alpha minus beta. So it will be sine alpha cosine negative beta plus cosine alpha sine negative beta. And we know that cosine is an even function, so cosine negative beta is cosine beta also. But here, sine negative beta, it will be negative sine beta. Negative sine beta, so this must be minus, not plus. And the same here. If this is negative beta, so sine alpha minus beta. Sine alpha cosine beta, and sine negative beta, it will be both negative sine beta. So this will be plus, not minus. I ask you to prove that tan alpha plus beta equals tan alpha plus tan beta over 1 minus tan alpha, tan beta. And then prove that tan alpha minus beta equals tan alpha minus tan beta over 1 plus tan alpha tan beta. Okay? Okay. How to use these problems? Sorry, how to use these rules to solve the problems? For example, if 5 cosine x plus 3 equals 0. طبعا اول حاجه ان هو هتستفزنا الايكويشن اللي قدام ان فيها unknown value واحد بس which is sin x. برافو عليكم. يبقى from this equation we must find the value of sin x. So cosine x equals -3 over 5. And then we must determine the quadrant, the possible quadrant which can draw the right angle triangle that express angle x. Cosine equals -3 over 5. So cosine is negative. So we have two choices. The first choice, second quadrant. The second choice is the third quadrant. So we can use this equation in both quadrants. But we have here condition here, right? So this is the second quadrant. In the second quadrant, we can draw right angle triangle like this one, and this is angle x. We must put the angle always with the x-axis, not with y-axis. And then now we have its adjacent and its hypotenuse. Its adjacent is 3, its hypotenuse is 5. We can find the third side using Pythagorean theorem. And after this one, we can compare the sides and the axis. What does it mean? The side of length 4 units is on y-axis. Which part of y-axis? The positive part, so it will be positive 4. But the side of 3 length in the negative part of x-axis, so it will be -3. And the hypotenuse is always positive. It's always positive, right? This is the first part of the given, and we use it. And we have another angle which is called y, and cosine y equals 12 over 13. Sine is positive, so we have two choices: first quadrant or fourth quadrant. He put condition here, pi and 2 pi. So we have two choices, third or fourth. And we have here two choices, first and fourth. So the common choice here is the fourth quadrant. We draw another diagram to express angle y. The fourth quadrant. Draw an angle triangle like this one to express angle y, and we said that before, it must be with x-axis, not y-axis. And we have here its adjacent and its hypotenuse. Adjacent 12, hypotenuse 13. So we can find the side lengths of the third side of the triangle by using Pythagorean theorem. So it will be 5. Compare the sides and the axis. 12 on the positive part of x-axis, but 5 in the negative part of y-axis. See, it's negative 5. The hypotenuse 13 is always positive. It's always positive. Now, find sine x minus y. Sine x minus y. The rules is sine x cosine y minus sine x sine y. Then we can use figures. Sine x opposite over hypotenuse 4 over 5 times cosine y, triangle of y, adjacent over hypotenuse 12 over 13 minus cosine x from the triangle of x, adjacent over hypotenuse negative 3 over 5 times sine y opposite over hypotenuse negative 5 over 13. Then calculate it. This is 48 minus 15. 33 over 65. Right? This is the first one. Second, cosine x minus y. Sine x minus y. The rule is cosine x cosine y plus sine x sine y. Also use the figures. Cosine x adjacent over hypotenuse negative 3 over 5 times cosine y from the right angle triangle of y adjacent over hypotenuse 12 over 13 plus sine x from triangle of x opposite over hypotenuse 4 over 5 times sine y triangle of y opposite over hypotenuse negative 5 over 13 equals negative 36 minus 20. So negative 56 over 65. Okay. To check your answer here, you can using the identities that sine square theta plus cosine square theta equals what? 1. Excellent. Equals 1. So we have here sine x minus y, and we have here cosine x minus y. If your answer is right, it must be 33 over 65 power of 2 plus negative 56 over 65 power of 2 equals 1. Check this is right or wrong. 33 over 65 power of 2 plus negative 56 over 65 power of 2 equals 1. And you can check your answer. Okay. اوكي كده تمام يا شباب. اقدر اقول لكم السلام عليكم ورحمه الله وبركاته.